Okay. All right, so it's 3:31, and so I'm going to start. All right, welcome back, everybody. Hopefully you had a good break, and this is the last session for today. And my name is Nithya, and I'm from DEKRA. I'm going to be I'll be the moderator for this session. I'll be introducing the three speakers. We are continuing the saga of open source and OpenSSL topics in this track, and it is track S13. If you were looking for another track, not the subject, this is the time to switch to the rooms. So our first speaker is Watson Ladd. He is a principal software engineer at Akamai Technologies, US. In the interest of time, we don't read the biodatas, all those things, all his resumes, at least a short form of it is in the booklet. Please do read. And he will be talking about supporting OpenSSL providers from a fork. Welcome, Watson.
Thank you very much for that welcome and coming to hear my talk. So we're forking OpenSSL, and I'd like to talk about why we're doing this, and why we have to support providers. So the reason we have to support providers is FIPS. I'll talk a little bit later about what providers are, why they were introduced, why we need that for FIPS. So one of the questions is, why are we forking now? And the answer is that Akamai has 25 years of continuous development on a gigantic C++ project that powers a lot of our products and enables a lot of our customers to provide websites you use every day. We also have extensions and customization. We have found a need to add patches of various size to OpenSSL to provide our customers with features that they need or to make internal users' lives better. We want features faster than OpenSSL. OpenSSL has a policy. They do not introduce features until the RFC has gotten published. Anyone familiar with the IETF process and the roles of companies like Cloudflare and Google and Apple and Akamai in introducing features and getting real-world deployment experience before we have them standardized knows that this is not going to enable us to be competitive. We care about performance. Make lives better billions of times a day, trillions of times a day. That is incompatible with taking milliseconds for an operation that used to be fast. Remember that existing code? We cannot rewrite it all to avoid the new slow paths. And security. When we talk about security in OpenSSL, it's not just the security of OpenSSL. It is the security of the entire ecosystem of software packages that support OpenSSL as a dependency. And that ecosystem security is harmed by choices OpenSSL has made. All right, let's talk about providers. Algorithm implementations live outside of OpenSSL. They can live in dynamically loaded modules. The provider lists information about what it enables. So it can say, I create keys of a certain kind. I can do things with these keys, like encrypt, decrypt, sign. It underlies the EVP layer. So you only access this through the EVP layer only if you call particular functions. Application and configuration interact to find the provider for an operation. It's on a pair operation basis. This is how FIPS works. For technical reasons, supporting FIPS in a statically linked thing is a pain. I have seen it done. I have contributed code to a project that did it that way. It was not fun. I then took that FIPS module and used it with a later version of that code. Even less fun. With OpenSSL, one benefit of this model is that it is possible to have an up-to-date application, use a FIPS module from an earlier OpenSSL, and so you continue to have FIPS as you roll out patches to applications. That's a big benefit from 3.0. Why do we need compatibility with existing providers? FIPS. 9 months, 6 figures. I hear those numbers have gone bigger. We need to have FIPS, our customers demand it. In order to have FIPS, any code we make that's in our OpenSSL package needs to use the operations, load them, get them from the FIPS module, and then use them. All right, so achieving compatibility. And how many people program against OpenSSL at one time or another in their lives? How many people, good number of people, how many people against 3.0? Handful, okay, so some people are unfamiliar with the changes. The provider interface exposes functionality through an array of objects that have various kinds of types and are identified by strings. Every operation goes through the provider looks through the array you passed it, finds the matching names, does the needful thing, and then returns you a similar array. That fundamentally underlies in operations like AES-GCM. You want to encrypt data with AES-GCM and OpenSSL, you pass in an array, it does strcomp on a couple of strings to load the tag. Then you do it again to retrieve the tag at the end of decryption. I am not making this up. This is an API that they decided was suitable for the highest performance operation in a modern TLS stack. The provider interface has a very dynamic thing. You can load or unload at runtime as the applications are there. It is complex. We have a moving target with a degree of integration. Providers don't just list operations, they list attributes of the operations. They list entries in IANA registries. So if you offer a new ECC group or a new keyshare operation, you can advertise what number should go on the wire, and OpenSSL is smart enough to look at what comes in from the wire, say, hey, does any provider I have know how to do this? Load that operation, carry it out, and do it. Your application might need to know how to say, hey, I want you to do this operation if you can. OpenSSL doesn't need to change for you to change the attributes of that provisioning. This is how Open Quantum Safe works. With 3.3, one of the big changes they made there is this now works for, and the complexities are pretty big, this works for ANS1 identifiers. You have an OID for a new kind of key, you can load it. It didn't require changing the provider interface. This is something they got right. It's more attributes being looked up, another subsystem being aware of these attributes, how to find them, how to find providers with them, enumerate them, get the operations, do the operations, and then cache hopefully some results so the next time it's less expensive. We would like to deal with this. There are new interfaces here from 1.1. These interfaces are slow. They are called on operations like serialize a private key. Just recently, I was fixing a bug where a team discovered that in a performance critical operation for them was extremely slow when moving to 3.0. The reason was that operations that used to be fast, like serializing a private key, now required this provider machinery to search through every provider quadratically because of the ways ASN1 parsing and OIDs interact with the provider interface. We would like a simpler API, right? If you think about encryption, there's a very simple set of things that every block cipher does. Or sorry, every encryption scheme does. It encrypts, it decrypts. You have a key, it does those things. If you have a chem, you encapsulate, decapsulate, generate keys. If you have a public key algorithm, it doesn't matter whether it's RSA with a lot of parameters or ECDSA with a much smaller number. You generate a key, you sign, you verify. That's the target of analysis. That's how these things are specified. Would like it, ideally, we would just like to list the function pointers and really have it be a much faster operation on the library side to get these operations and to call them. We don't want to have to go through a complex lock-filled data structure on every single operation. This did get better. For various reasons, we haven't been able to take full advantage of the things we can talk about it later. And this is sort of a suggested solution. The EVP layer still has to understand engines in addition to the provider interface. If you're an application and you're using providers, you're using EVP. The old lower layer functions are still there. They don't go through the provider interface. So we could go take advantage of this faster pointer-based thing. There's some mismatches. So if you think about the EVP layer, they have this new EVP context thing, or maybe it's old. It's not new, sorry. And there, it's sort of a more complicated thing, right? You don't just take a key and encrypt. You take a key, you produce a context, you can copy a context. What does that mean? Copy in data, do the thing, do the operation, and you save some time, you have some state around you can do for the next operation. So we have to think through this. We don't really have a completely worked out solution. But we're definitely interested in thinking about the design space, thinking through the solutions that are going to solve some real pain points. And then the formats. So this is one where we really do not have, or I at least personally, do not have a great idea about how do we make the ASN1 OID thing fast. Because fundamentally, do I maintain a table of OID to provider mappings? The provider choice might also be influenced by application things. Maybe it's a big complicated table. I don't really know the answer there yet. We'll find a way. So bottom line of where we're going with this, the providers will continue to work. This isn't going to stop evolution. There are things like memory safety where we've seen alternative projects make strides towards getting rid of what's a serious issue for OpenSSL. Post-quantum. The provider interface has been used to implement a lot of post-quantum things. We can still do that. Better interfaces. So one thing I didn't mention, a little bit of that passing around the provider stuff has leaked into applications. By stepping away from that, it's a motivation to produce better high-level APIs for applications to consume that will let us evolve the layer underneath rather than have the provider constrain how the application works. And ideally, we'll get back that performance. We'll get back to where we were with 1.1.1 in terms of speed. That's a long ways. That's going to take work, but that's an attainable goal in a way it isn't with the provider interface. And also, we will play nicely with the community. We understand that free and open source software projects are under-resourced, don't always have the ability to maintain code depending on dependency. This has forced some painful choices onto projects like OpenSSH, where they care about one particular fork, would like to support the common subset, leaves them wary of adopting 3.0 APIs, leaves them in a bit of a pickle when it comes to things like, I want to use FIPS. And I expect there's lots of questions about this, so I'd like to hear them. Sorry for running so far under, but come on. Yes, in the back. Use the mic, please. I think there's... Where's the mic gone?
It's probably with him from the last. That was really good.
Yeah, sorry, I rushed a bit. It's...
Okay. It works. So, okay, great. Thank you very much for that presentation. And I just have a heretic question. I mean, you were complaining a lot about OpenSSL. Why stay with it? Why not moving it away?
We are, by taking patches independently. So we have had, for the past 6 years, I believe, had to maintain a separate set of quick hooks on top of OpenSSL. Every OpenSSL release, we go rebase them, and we would take the patches on top. That has become less feasible in later releases. And the sort of message here is that we are changing this. Why we didn't do this earlier? The answer is it's back then 15 years of software that is built around every corner of the APIs. it's not feasible to port it all to a new implementation. And this is, I think, a very real constraint when it comes to the evolution of the ecosystem.
Okay. In addition to that, I mean, there are 2 forks already out there which are kind of API compatible, like Boring or LibreSSL. And what about those?
Okay, so we'll start with Boring SSL. Boring SSL does not do releases. They very much live at head. Akamai very much does not. We can have a conversation about that evolution and choices there. The FIPS support is very Google specific in a way that's hard to use. And also they are very, very aggressive about changing APIs. Remember, they can see every single usage across their multi-million line code base and change it to use a new API and put in that new API and remove the old one in a single atomic action. We don't have that capability. That changes the strategy. Now, there are places that have relied on Boring SSL that have built on top of it. They've expected breakage across the products that do that. They've dealt with it. That works for them organizationally in a way it doesn't when you say, okay, we maintain the install that works across all the packages, and you don't have the ability to make that kind of gigantic cross-cutting atomic shift. So that's a software engineering issue. When it comes to Libra, they don't care about FIPS at all. So that's a different obstacle. But yeah, really it comes down to the nature of the software we have to deal with, which exercises parts of the OpenSSL API that honestly I wish we didn't. And with the need for FIPS compliance.
Okay. Thank you very much.
So I guess my question is that up until now, the Linux system software community has consistently used cryptographic APIs that happen to just be the API of a specific piece of software. And if you look at a completely different domain, like, for example, graphics, where you have things like OpenGL or Vulkan, those are ecosystems where the API is the product, and you have people actually putting proper thought into API design. So I was wondering if you thought that it would make sense, really, for the community to say that actually we need to be stop just tracking the API of a specific piece of software that we're definitely always going to rely on, and really people should be doing something more like, PKCS11, but suitable for the applications on a Linux system where you actually have an API that is designed to be as high quality as possible, and not just something that one piece of software decided to ship.
Right, and to be clear, the software designer was in some cases an Australian teenager learning big number arithmetic. And this is part of the constraint here on their side. I'm sensitive to the fact that we have a lot of legacy stuff. And you're asking a question about why the APIs didn't evolve the way they did. I don't know. Robert Vallejo, who's worked on NSS, which implements the PKCS11 interface internally and then has to unwrap it to do anything useful, it's quite... Yeah. I've worked on that code.
I mean, my feeling is we need, Windows has a standard API independent of the implementation.
Right. Windows has Windows has the crypto API they've changed the underlying thing for. Yeah. Right. Why is this happening with crypto? Why aren't we moving that way? And I think
Vulkan for Linux for crypto.
Well, I mean, but Vulkan builds on OpenGL, and I think
threw out OpenGL.
Now,
it threw out OpenGL. Very comprehensively, if you sort of look at it.
Yeah, but there was a tradition there, right? Yeah. There's a tradition of the hardware manufacturer. I think this is the big difference. And I'm making this up. I was not around for these decisions, as you might tell. In hardware, there was a clear benefit to, I want to compete by being the best graphics card in the market, the fastest one, that makes all your games faster. As a game software engineer, I want to be the one that looks good when the new card comes out. I don't want to have to write code for Voodoo, all the cards that came before OpenGL separately. And as a maker, I want to access that library that people already have put money into and make it look good. So there was a clear incentive on both sides to create an open API, to move extensions that were specific into common thing. I think when it comes to the software, there's been a lot of historic challenges to defining these APIs in an interoperable way.
Yeah.
I know that with web crypto, there was resistance to defining any sort of mandatory to interrupt thing. I don't know whether the excuses given were true. The excuse given was one about export controls. I am not an expert. I'm not going to say whether it was true or not. That was what I heard.
No.
And I think the other issue is the intermeshing at this point, right? Applications have come to OpenSSL for very different things. Some have come for low-level crypto operations.
Yeah.
So something like Kerberos is calling a bunch of individual cipher modes and putting together a bigger protocol. Something like OpenSSH is doing the same thing, right? It's calls the low-level functions, it's doing its hashing, it's doing its key agreement, it's implementing the SSH protocol, which looks really different. A lot of them just do TLS. I think if the ones that just use TLS had a high-layer API, we'd all be in a much happier place. That evolution has, why it hasn't happened, I think partly is resistance to doing that. You can't go implement, it's very difficult for a software project to come into being and get adopted as a library that will be shipped on places enough for application vendors and developers to adopt it. And so the leadership there would have needed to come from OpenSSL, who, for various reasons, didn't exercise it over the evolution of the software, of the ecosystem.
Yeah. Thank you.
Any more questions? We still have a few minutes left. We have 7 minutes left. Any more takers? Okay. In that case, thank you very much, Watson. Let's give him my hand. Thank you. And in any case, mark your calendars. You have to stand on the line, get your lunch, and if you can eat it within 15 minutes, that's fine. Otherwise, just bring it. Bring it, and we will meet in that hall. I think it is the next room because it's Friday. I'll check with Bill and let you know. So we'll have 45 minutes. It will not be a whole hour. It will be only 45 minutes or even less because we need to also clean the room. If it's one of these things, we need to also make sure we clear up so that the next session goes on time, right? So I'll give about 5-10 minutes for that. So it may be a less than 40 minutes, about 40 minutes or so. So please, if you have never been to the CMUF monthly call, I encourage you to come and sit down and listen to what goes on. If you have been there, please do come and see the people that you hear the voices of, and both CMVP, CAVP, everybody will be there. So I'm not sure they will have time to ask a lot of questions and get answered like we usually have during the monthly meeting, but at least you will be able to put a face to the voice and be able to ask them question directly whenever you get a chance later. Okay? All right. Having said that, I think we are hitting the time. Yes, it's 4 o'clock. And again, just to remind you, you're on track S13, open source cryptography support and validation. And we have the next speaker. Our next speaker is Randall Steck. He's a founder, CEO, Symbiotic System Research LLC. And we were supposed to have one additional speaker, Steve Wayman from Kipe. Unfortunately, Steve came down with COVID, so could not be there. So he will take both loads. All right. And Randall will be talking on taking OpenSSL 3 to FIPS 140-3. Welcome, Randall.
Hi, everyone. Thanks for joining. Just wanted to give a talk about the efforts that myself and KeyPair Consulting took together to validate OpenSSL 3 at the 140-3 level, the engineering and architecture that went into to creating this product. So as a little overview, project timeline, the module algorithm changes, configuration work, and then additional related work we've done to support the validation. So project timeline. Coming out of ICMC 2021, OpenSSL announced that they were going to be doing a 140-2 validation. This is, of course, the year that 140-3 really hit, and there was some surprise that they were not doing a 140-3. So I immediately ran out and contacted KeyPair and said we should do something, and they agreed. So we started our efforts. That was in the fall of 21, and we made our initial submission in the spring of 2022 based on a 301 at that time. During the process, we were able to rebase on 3010 and pick up all the improvements and additions since then. Just a couple of weeks ago, on July 11th, I guess more than a couple of weeks now, we received certificate 4724, so we are officially FIPS validated. And we are the first OpenSSL 3 validated at 140-3. And I believe at this time we are the only one available. We're also the only one with a full validation. OpenSSL announced that rather than going after an interim, they're going to go after a BR1. So at some point in the future, their 3.1 version will also be a full validation capable of rebranding. We were managed to get ours as the BR1 thanks to Herculean efforts by Steve. That was some of what his participation was going to be. But we did manage to get a full validation. So there's a lot of changes that had to get made. I just wanted to sort of overview some of those changes. I've grouped them together as reasonably as I could. The first is the module integrity test. One of the new FIPS requirements was that the underlying algorithm that had to be validated before the integrity test took place. OpenSSL had architected that the HMAC was integrity tested, was tested as part of the KDFs. So there was not an explicit HMAC test. So what I did is I extracted, took the SHA and modified it to an HMAC and then plugged it in as part of the startup. So as part of the integrity test, it goes ahead and does a cast on the HMAC and as so the underlying SHA as well. And as part of that, we also zeroized the integrity value after computation. That's one of the FIPS 140-3 requirements. Also, coming out of 140-2, the code contained the option to not run the integrity tests at runtime, relying on 140-2 IG that said that you could do that once on installation and not at every runtime. That was not possible with 140-3. That IG was not carried over. And as a result, we enforced that the casts are run each time. Due to the way the FIPS install works and various other parts of OpenSSL, we decided to leave the option in the configuration file. And so when you do FIPS install or you check your configuration file, things like that, it all works as it's supposed to. But when you actually go to run it, it ignores whatever that setting is and runs the casts automatically at startup. So that was one thing that we had to maintain. Also, as part of module startup, this is one of the more challenging ones. Pairwise consistency tests were no longer allowed. They had to be known answer tests. Of course, DSA, ECDSA, and the Edwards curves contain entropy and therefore can't be done normally as a cat without having some control over your DRBG. So for that, I had to implement a test DRBG. So I copied over, borrowed the code from the cast, and made a substitutions where I can swap the root DRBG for a test implementation that's under our control. I feed it the appropriate entropy sources that we know, and we get valid results. We get known answer computed results. And then we swap that back before we hand control back. So basically just on the underlying, I'm going in and taking over. And this is the parent DRBG, which is the underlying one that all subsequent ones are based on. So at this point, even if you did generate a new one, you'd get that. I did include a little bit of the swap code. I don't think you can really see it from that small size, but if you look at the presentation afterwards. And basically all I did is I swap out the new DRBG test, cache the old one, run the test, you call this function again, it swaps it back. just to make sure that we maintain the operations. Moving on to some algorithm changes, we removed triple DES. We removed it both from the build.info and the provider capabilities queries, so it is out. And since it's not in build info, it's no longer a part of the FIPS.so, so we saved a little binary space as well. One of the requirements from IG 9.5 implemented 2 independent actions for the plain text CSP output. This, of course, relates mostly to key wrapping. And so the first action that one takes is adding an entry to the configuration file called allow plain text CSP output. And this first action is assumed to be done by the administrative user. And then the second action is the actual API call. You would not be exporting if you didn't ask to export. So those 2 actions. And a typical configuration will allow the plain text CSP output. We include that as the default. So if one wanted to modify it, they could modify the configuration file itself to disallow that. The last, another algorithm change, the HMAC and KMAC have minimum bit requirements, and we added those minimum key sizes, which were not present in the FIPS module. And last, Edwards curves. These were, of course, not part of the 301. Well, they were in 301, but were not complete. We implemented the required pairwise consistency tests for signature generation and verification CATs. Along the path of modifying these, I noticed that the context string, which is a requirement for algorithm testing and proper complete usage and implementation of the algorithm, was not included. There's actually a particular function, I have it listed there, where those were actually nulled out. So a lot of work was done to include the context in the low-level implementation of the Edwards 448 curve, but the actual API that implemented just zeroed them out. So I added the variables necessary to the context, and then the parameter set so you could set those. And then I modified those 2 functions to pass on what was provided. And after that, it pretty much worked. So they did all the correct work to implement it. For some reason, they just closed the door on it. We opened it. Key exchange using Edwards, it remains non-approved for 140-3. So in our implementation, only signature generation and verification can be used. The key exchange is marked as unapproved. So even if you have only the FIPS provider loaded, you can still get to those. You can still do all key exchanges. You just have to take a special provision step to do it. Configuration. The module HMAC under the default OpenSSL is included in the FIPS module.cnf file. But that necessarily means that the configuration file must also be included in the boundary, because the MAC must be included in the boundary. So what we elected to do was to separate that out into a separate file that contains only the HMAC, and then we use the .include mechanism to include that in the FIPS configuration file. So our boundary includes the FIPS.so and FIPS.so.mac, and then we just point to that in the configuration file. We had to add a special provision in the FIPS install application so that it would write that file correctly and to a separate file and make the include. As I mentioned previously, we modified a couple of options, allowed the plain text CSP output, and ignore the install status, which is the flag that sets whether the casts should be run at startup or not. And then last, we shipped modified configuration files so that coming out of a default configuration and install, you have an operational environment that is included only the FIPS and base. And at that point, if one wanted to, a FIPS only installation, if one wanted to install the default provider, you can modify configuration files to do that. The OpenSSL unit tests, or the big testing folder, thousands and thousands of tests written in Perl. Many of those tests were affected very wildly. Everything from testing out the various TLS mechanisms and their key exchanges, and they include DES as a default. There's a lot of work to modify those. That is an exercise I will leave to the reader as to what has to get changed and how, but that was not a fun task. And then as part of our complete package, we wanted to provide a bunch of other tools that would assist our vendors in compliance. So we wrote a verification tool. Very simply, it's a first step after doing an installation. You give it the configuration file, the OpenSSL CNF, and it performs a bunch of tests to make sure that you're all installed correctly. A very quick and easy test. But the real magic comes in an op test tool that we wrote that will exercise all of the new features that we have implemented. We rely in some part on executing the tests, the default unit tests, as a demonstration of op testing of compliance with basic operational services, the services all operators are supposed to. And then our op test tool is written to execute any number of other features of our software to demonstrate those on a one-by-one basis. We rely on the OpenSSL touch points, their testing touch points, to receive callbacks, modify bytes, and so forth. And as part of that, we did add a number of entries there, specifically regarding the cats and so forth, so that we can make necessary modifications and show failures in those cats. And then we also demonstrated the Edwards key exchange issue, both with a FIPS, a default, a FIPS, and then a non-approved FIPS to show that all worked. So I have raced through my time, but at this point, I'm happy to take any questions anyone has. Can you please use the microphone?
Could you?
I'm not sure about this, but there was also some difference in respect to DRBG chaining with respect to 142 and 143. So did you need to make any changes there inside OpenSSL or?
We did not. Didn't make any changes regarding chaining.
So, okay, because my understanding was that 143 specs disallows that, and so, I mean, there would be some issue there, but evidently not.
We received no feedback from the lab or the CMVP on it. The default OpenSSL configuration is you have a base provider that's hidden in private opaque, and then every time you create a new context, it uses that as its backing, as its entropy source, effectively.
Hey, I just want to know, did you do any cross-compilation testing when you were setting up for your code changes?
Yes. So as part of our validation operational environments, excuse me, we have various Linux flavors. There's a Red Hat on there. There's some Ubuntu's and so forth. IBM AIX is on there. We've also validated, will soon validate and put on our certificate a Windows installation. I've personally played around with Mac OS. We haven't actually done a validation on that, but I've run testing, compiled and run testing on it. So that's what we have so far. I have confidence about things like, we've also done BSD. I have high confidence based on previous experience about things like Solaris. HPUX might be a little more challenging from libraries and standard libraries and so forth, but I don't expect any issues there. We've compiled on ARM, we've compiled on MIPS, we've compiled on Power, Intel, AMD. I've compiled and run it on a Raspberry Pi, any number of systems.
Hi, Randy. Thank you for the presentation. You mentioned earlier that you had a lot of adventure with the tests. Could you talk about that a little bit more since we have a little extra time? Like,
Sure.
what was your adventure and what could others learn from you?
Sure. So the first adventure was it's all written in Perl, a language I have no experience with whatsoever. And the language dynamics are not, not necessarily easy. So one of the challenges is, in a lot of those, there's already a built-in understanding that the tests have to be slightly different or cover a slightly different set of circumstances for FIPS and non-FIPS. So there may be an occasion where, these sets of tests are within a larger framework. These sets of tests are run for non-FIPS, and then these are also are a smaller subset for non-FIPS or for FIPS work. But it's not consistent across the various tests how that's done. In some cases, it's a separate array list of these tests are run versus these tests are run. Sometimes it's a subset, superset situation. Other times it's not. There were cases where we the Perl was written in such, and there's a C component that runs behind it, that Perl calls a C component also, where it got involved enough that we would have had to make some major modifications. And the whole point of these is to prove that our modifications haven't modified what was done before. And if we then go and modify the test so significantly, we have trouble demonstrating to a lab that it's not the test that we've modified to show it correct even when it's not. So in many cases, like for the DES, in some cases it was possible to just remove DES as an algorithm from being tested under FIPS. So the non-FIPS tests DES and the FIPS does not test DES. In other cases, we had to remove DES as a test entirely because there was no way to differentiate them default and not. So those are some of the challenges. The other was a scope. There were, I'm trying to pull up numbers. There's something like 1,400 tests that are run, and I think in the neighborhood of 300 to 350 failed. So that's a significant amount, but realize that one particular Perl script might run 30 tests, 35 tests. So you start knocking them out in reasonable chunks when you do that. When you remove DES, there's 40, 50 tests and things like that. So there were, in the end, it turned out most of the cases we were able to pare it down with a surgical knife and get just what we needed to. In other cases, we kind of had to use a band hammer and just say, we're not going to test that. So effectively what we do is in operational testing, we'll sometimes run the default provider and run all the tests to prove that all the tests still pass. And then we set it up using a different configuration file to run only the FIPS plus base and run all those tests again. And we are producing all passing tests. So we don't have any sort of built-in failures that we've left there, but by comparing the delta between the two, you can see what we've left out. Great question, thank you.
Yeah, thanks, Valerie. It took some time. That's good. Any other question? If you don't have, I can ask one question.
Sure.
So that was a very interesting presentation. Thank you for that, Randall. And you saw an opportunity and took advantage of that. That's very good, and I'm sure it helped a lot of users. Are you planning to do quantum now?
We're in discussions on it. One of the issues in doing what we've done, independent of OpenSSL group itself, is that we take on a burden and responsibility of CVEs, changes, rebasing, et cetera. There will come some point in the future when we revalidate entirely, probably on a 3.4 or 5, whatever is appropriate at the time. And that will probably include some post-quantum at that point. There are no specific plans as of yet that are firm enough to talk about. But the rebasing issue is something that is actually an interesting talking point. I think it's in there on an earlier slide. We rebased on 3.0.10 during the course of our validation. And of course, I think we're up to 16, 18, 14, I don't remember where we're at exactly, but we've tested all those interims, 3.0.1 through 3.10, and after that, 3.0.10. I've rerun our patches and made sure that everything changes, and we've monitored what changes in the FIPS module, et cetera. If I had one overarching comment on that, it's that under 1.0.2, there was obviously a completely separate source code tree for FIPS. And the canister got embedded in, and then you had 2 sources of source code. That's a problem. I don't at all disagree with the decision to use a unified code base and just simply differentially compile the modules. The issue, unfortunately, is that anytime there is a change in any file that's included in a build.info for the FIPS module can technically be a change in the FIPS module, which means there is a FIPS validation justification problem in doing any kind of updates. So we have tested out running our 3.0.10 FIPS module with 3.1, works perfectly fine as OpenSSL says it should. We haven't gone any beyond 3.1, but I imagine we would get the same results with 3.2, 3.3, et cetera. But this is perhaps something that OpenSSL needs to look at in the future. Is there a better way to organize the files, organize the build.info, such that when they do need to make changes in FIPS, it's not just bracketed by a precompiled definition of if FIPS module or not, because sometimes that's insufficient. One of the solutions we took is that we actually copied files out of the source tree and copied them under our own FIPS provider, the provider's FIPS, as our own tree under there, and we copy into that the original source code file, make our changes and modifications there. We did that if we felt that the modifications were so large that they were likely to trigger, interfere, overlap with file changes that might come along later, and thus we insulated them from doing so. Make changes to the build.info so it only includes the ones we want. So that was what worked out for well, but that is going to be a point moving on is, there's a maintenance issue there, and the OpenSSL group may be able to help.
So have you had a conversation with the booth people there, the OpenSSL?
I have. There's one other point of the history and lore of this I didn't necessarily go through. So once we decided we were going to do it, KeyPair contacted OpenSSL group, and we started negotiations, discussions, I should say, more appropriately, early on about the ways we might be able to work together on this. They wanted to remain focused on 140-2. They did. We wanted to remain focused on 140-3, and we did. And we went through and did all of our legwork. We made our submission. After we made our submission, they had made their 140-2. They were looking at 140-3 and came and sniffed around and said, what'd you guys do? So we again discussed it with them. In the end, we provided them our patches. So OpenSSL group received all the work I did. And all I will say is that served as a inspiration point, a touch point. They made their own decisions about what to implement and how to implement it. There is some of that original code from ours that ended up wholesale in there, but a small amount. But nonetheless, we have been in coordination with them. They were fully aware of our efforts as we were going on. We got a nice reference earlier today. Someone was asking about taking the code base and doing your own FIPS validation on it, and they mentioned us, so we appreciate that. And we remain in discussions. We work very well with the OpenSSL group. We have very good relations with them, and we hope to continue.
But you're not open source, right?
No, we're not open source. We're commercially available and for rebranding and adding to our validation.
Excellent. Thank you very much. Do you have anyone has any new questions based on these conversations? No? All right. Thank you. But that was very interesting. Thank you, Randall. All right. We still have interested. Actually, it is open for anybody and everybody. It doesn't have any subscription to join. All you need to do is send an email to cmuf.org, admin@cmuf.org, I think is the email address, but don't take me on that. Just do a CMUF Google and you'll find that web page, and then you can send an email saying that you want to be a participant, and there's a few things, I think first name, last name type of things, and then you get an access to it. Every month we have a meeting, every month except 2 months, right? So out of the 12 months in a year, we do 10 monthly meetings. We do not do a monthly meeting in July and December. July is generally everybody is on vacation, so we don't do it. December is, again, vacation time, Christmas time, so we don't do it. But all other 10 months we do have a meeting. Let me not go too far. So I still have 1 minute to talk more about. So this monthly meeting is run by one of the steering committee members, and there are 7 steering committee members at this moment. So we run that, and we invite all the CMUF, all the NIST folks, and the Canadian CCCS, program managers. All the managers come in and give us an update on where is the queue, what is happening, what are the IGs that are going to be released, what are they working on, and everything. And then we also have another group, another set of people who talk, who are the working group leads. So they talk about each of the working group and then say what is the update since the last month and what have you. And then there is an open forum. At the open forum, anybody can ask any question to any of the speakers or have a discussion point. So that usually takes about 1 hour call. It's about a 1 hour call. And it's on the 3rd Tuesday of every month at 11 o'clock Eastern time, right? So hopefully you all can join in case you have not been aware of that. Thank you, Valerie, for letting me know that. So I can, 4:30, I'm saying 1. So yes, we have 4:30 and we are in time. Last but not the least, for today, we have another OpenSSL, and this time the timeline on OpenSSL validation. Our speaker is, I know her first name, not the last name, so let me see. Apurva Varalikar, and she's a lab manager, Acumen Security, US, and she's going to talk about OpenSSL FIPS validation updates.
Thank you, Nithya.
Welcome.
Oops. Okay, so thank you for joining me. This should be super quick and hopefully painless. All right, so for those of us who are not familiar with the term FIPS, it stands for Federal Information Processing Standards and is a joint certification program between NIST in the US and CCCS in Canada. So many of us here might already be aware the OpenSSL library as a whole has not been validated, rather a component has been. In the past, this was the FIPS object module, commonly known as the form, followed by the OpenSSL FIPS Provider 3.0, and more recently, this has been the OpenSSL FIPS Provider 3.1. So what is the form? The form essentially is a single binary which consolidates all approved cryptography in it. And depending on the underlying platform on which it executes, it can either take the form of a fipscanister.o file for Unix-based platforms or fipscanister.dll in case of Windows-based platforms. It was first validated between the years 2012 and 2018 and associated with the OpenSSL 1.0 and 1.1 releases. Sorry, I have old lady voice today. So given when it was last validated, the certificates have moved from the active to what is known as the CMBP historical list of modules. In other words, the certificates have expired. And this is because from its date of issuance, a FIPS certificate is typically valid for a duration of 5 years, and that duration has elapsed for the form certificates. This means that there's limited revalidation options on the table. Specifically for the form modules, given that they are on the historical list, there's 2 different revalidation options. The first one is known as a scenario 1, option 1, and this is where you can, OpenSSL can make some administrative updates to the certificate, such as updating the vendor point of contact information or making non-security relevant updates to the security policy document. The second is known as a scenario 3A, and this can be used to address any vulnerabilities or CVEs encountered in the module, and the patched version of the module can then replace the existing version. So these 2 are still possible even with the historical status. And here's a list of all the form validations over the years across the different versions of the module. Okay, so next up we have a snapshot of the cryptographic boundary for the form, and this is straight from the non-proprietary security policy document appended to a previous form certificate. The red demarcation here denotes the cryptographic or the logical boundary of the module, which as can be seen is nothing but the form module itself. So this is the FIPS scope where all of the FIPS requirements would essentially apply. The users of the module in this case are the applications calling into it, invoking APIs and services from it. The services, of course, are the cryptographic primitives or operations provided by the form. And finally, the general purpose computing platform on which the module executes comprises what is known as the physical boundary of the module. And it's worth noting that the terms logical boundary and physical boundary are specific to FIPS 140-2 and are no longer used in the newer version of the standard, FIPS 140-3. The correct terminology per 140-3 would be cryptographic boundary instead of logical boundary, and physical perimeter versus physical boundary. So that brings us to the FIPS 140-2 provider. It's a dynamically loadable module which can optionally be enabled as a configuration option in the OpenSSL library. It was validated in the year 2022 and associated with the OpenSSL 3.0 release. Given when it was validated, the duration of 5 years of its validity has not elapsed, so the certificate still remains on the active list. This also means that there's additional revalidation options for the provider as compared to the form. So for the form, there were essentially two options, the scenario 1, option 1, and scenario 3A. For the provider, there's, like I said, a couple additional, namely scenario 1, option 2, which essentially can be used to make non-security relevant code changes to the module, and the new version of the module can be added to the existing certificate. An example of this could be fixing bugs. The FIPS lab, of course, is responsible for verifying every single change proposed to the module to ensure that it is, in fact, FIPS irrelevant. In other words, that it does not impact any of the FIPS requirements. The next one is scenario 1, option 4. This is a scenario that can be used to test the module on new operational environments, and then these can be added to the existing certificate. An operational environment basically is the combination of the processor, operating system, and the underlying hardware server on which the module runs. There's also the scenario 3B. This can be used to address algorithm transitions impacting the module. So an example of an algorithm transition would be the triple DES transition that was spoken about in an earlier talk. An algorithm transition can basically be thought of as a deadline set by NIST, whereby after that date elapsing, a given algorithm or a set of algorithms will no longer be considered to be approved. And depending on the nature of the transition, it could either be classified as a hard transition or a soft transition. A hard transition is one where certain actions have to be taken in order to be able to maintain the certificate on the active list. And failure to take these actions will, of course, result in the certificate moving from the active to the historical list. A soft transition, on the other hand, does not require any action so long as the certificate, the module has been submitted to CMBP prior to the transition deadline. It will get grandfathered in. So in case of a hard transition, the scenario 3B can be used. The required code changes such as implementing additional self-tests or adopting a new algorithm standard, whatever it be, those changes can be made and the new version of the module can then be validated. And here's a link to the currently active FIPS 140-2 certificate for the provider, cert number 4282. So here we have the cryptographic boundary depiction for the provider, and similar to the form, the red demarcation denotes the logical boundary of the module, which again is limited to the provider itself. So the FIPS scope is quite comparable between the form and the provider, which essentially begs the question as to what the difference is between the two. So in the past, the form had to be downloaded and built separate from the OpenSSL library. That no longer is the case with the provider. The provider is well integrated into OpenSSL. You essentially have to enable it. And you also have to ensure that your applications are calling into the FIPS provider and not the default provider. Okay, so this brings us to the FIPS 140-3 provider. This essentially, of course, is intended to be compliant with all the new requirements under the 140-3 version of the standard. The standard, of course, transitioned from -2 to -3 in September of 2021. And as of September 2026, all of the currently active 140-2 certs will be moved to the historical list. So it's imperative that the provider be validated under -3 prior to this deadline. And it's basically well on its way to doing just that. It was submitted in December of 2023, and here's a snapshot of the public listing known as the MIP or Modules in Process list, which essentially is a list maintained by CMBP on their website with the objective of providing a daily status of modules that have been submitted but are pending validation. So as can be seen, the current status of the module is that it's pending a review. So once a CMBP reviewer has been assigned, this will then update to in review. After a round of review by the CMBP, comments will be issued to the lab. At that point, the status will further update to coordination. The lab, of course, is responsible for addressing all of the comments, and once every comment has been satisfactorily closed out, a draft certificate will then be issued for the vendor and lab's review and approval, and this stage is known as finalization. Once this certificate has been reviewed and approved, at that point, the official 140-3 certificate can then be requested. So the future is bright, and here's why. Similar to FIPS 140-2, FIPS 140-3 also has the provision to rebrand modules. Rebranding essentially means that a given vendor can take a validated module and private label it or rename it as their own. And this comes with the obvious advantage that you cut down on the overhead involved in a full FIPS validation. You, of course, need the OEM, or in this case, OpenSSL's permission. You would also need to be under a premium support service contract with OpenSSL and engage a lab. And then OpenSSL modules, as many of us here might already know, have had a long history of being rebranded under 140-2. So recently, CMBP announced that the RBND, or the rebrand scenario, is available under 140-3, which is tremendous news, because once the provider has been validated under -3, it will then be available for rebranding. And that's essentially very important given how widely used the OpenSSL library is across the industry. Okay, so if you're interested in learning more about OpenSSL, FIPS, or Intertek's offerings, do stay tuned to the OpenSSL, CMBP, and Intertek pages. I also want to call out something that was also mentioned in a previous talk. Not every version of the FIPS provider will undergo a FIPS validation. So it's perfectly acceptable to pair a validated version of the provider with a compatible OpenSSL, and the instructions for doing that are in the README file. The other thing I'd like to note is Matt Caswell of OpenSSL has done a series of excellent presentations on the different providers in the library. So if you're interested in learning more about OpenSSL or providers in particular, I'd highly recommend checking those out on YouTube. So that's it from my end for now. I hope this was informative and, like I said, painless. And thank you for your time. So any questions?
Sorry,
Yep.
Apurva, I may have missed this. Did you say it's already validated?
No,
the
it's
certificate?
submitted as of December 2023, towards the end of the year last year. So it's currently in a review pending state, the 140-3 version of the OpenSSL FIPS provider.
It's in the review pending state.
Correct,
It's in the queue.
yes. It's in the queue.
So now I think I also heard OpenSSL say that they didn't want to do interim.
That is correct,
Right?
yes. And that basically goes back to CMBP direction that an interim certificate, at present at least, cannot be rebranded. What sorry to cut you off. What we've learned as of yesterday is that CMBP will consider this and maybe get back to us prior to the official deadline, which is October 1st, whether or not an interim certificate will be eligible for rebranding. So the final verdict is still not out.
Okay.
Yeah.
So, no, but if they're not going to get interim, then there is no certificate to rebrand.
As of now, correct. But they are, as was in the OpenSSL talk as well, they're directly upgrading to BR1. So, their path to getting validated should be quicker as compared to the conventional 140B route. So once they have been validated, at that point is when they can be rebranded.
And the report was submitted before December 31st?
Yes, December 29th to be precise.
So it's not BR1 compatible?
It's not BR1, they're proactively upgrading, essentially.
But they have updated
yes.
to that.
They
All
didn't
right.
have to, but they decided to.
Thank you. Yeah, I think
Sure.
there's a question.
Yeah, actually, that was my question. Was
Okay.
Okay.
Yeah, exactly about the interim.
Yeah. So it wasn't a mandate, but that's something OpenSSL decided to do. And like I said, because an interim cert as of now is not eligible for rebranding, so anyone who wants to get rebranded essentially has to do a direct update or stay the course with 140B.
Yeah. So will they be updating it? Is there any other question you have?
Well, so presumably, if it does go into review and then coordination, will the security policy be a BR1 security policy once approved and posted?
Yes, that's going to be the final version.
It has to be. No, the CMVP is not taking unless it is already in coordination, they're not taking non-BR1.
Okay.
Security policy.
So for the you mean for the interim, right? Yeah. So if it's an interim candidate, then it will eventually have to be upgraded to BR1, even in that case. Go ahead.
Don't you think it's like, even rebranding a 2-year certificate, it just seems like a lot of work, short period of time. So I think it's probably best for rebrand customers to just stick to the queue and then get an official certificate rather than a 2-year certificate and then have to do it all over again?
So it depends on what your internal transition is going to be. A lot of our vendors are still on the 140-2 providers, so those can still be rebranded. They're good till September 21st, I think it is, 21st, 22nd, 2026.
Yep.
So they have a good couple years on them now.
That's right.
So you can stay the course and but if you're going to start your FIPS validation now, looking at the current rate, it just makes sense to wait for the 140-3 provider to be validated and rebrand that. Why do all the additional work yourself?
I agree.
Yep.
What platform was this validated for the current? What platform was it tested on?
Right, so it's been tested on both Unix-based platforms, Mac, of course, as well as Windows.
Okay,
Yeah.
so all 3 are kind of covered.
FIPS.so, DLL,
Not all
and the Mac
versions,
variant.
but some kind
correct.
of. Any other questions anyone has?
Okay.
All right, if we don't have any questions.
Yeah, have a good evening.
Thank you, Apurva. Thank you very much.